Welcome, everyone. We're really glad that you're here with us today for today's webinar on the RSAP Atlas, a data and mapping tool for planning. It's great to see so many folks here. Please continue to add your name and where you're coming from in the chat. Seeing we've got folks from different cities, counties, nonprofits in here, consulting groups, environmental groups. Looks like we have a really great diverse group today. My name is Jackie Perrin-Martinez. I'm the Climate Adaptation Planning Manager at BCDC. And this is the third in a series of webinars hosted by our team. And today's webinar will focus on the RSAP Atlas, a data and mapping tool developed to support the creation of subregional plans as required by the Regional Shoreline Adaptation Plan, or RSAP for short. The Atlas is part of a larger effort by BCDC to help communities prepare for sea level rise in a way that's informed, coordinated, and locally grounded. Our goal with this tool is to make it easier for planners and practitioners to access reliable, regionally consistent data and apply it directly to the development of their plans. If you didn't attend the first two webinars in our series, we encourage you to watch the recordings that are posted on our website, but they're not required for today's content. Just a few tech tips and webinar norms. We encourage you to use the chat to share your thoughts. As you can see here, we already asked you for introductions. And please respond in the webinar chat to our audience engagement questions. We'll have a few today. If you have a specific question for us, please use the official Q&A box. You can find this at the bottom of your screen. There's kind of two speech bubbles. You're welcome to submit official Q&As throughout the presentation, and then we'll address them in the Q&A section. So if things come to mind, feel free to drop them in, but try to kind of be mindful of where you're putting your answers in, so that way we know to get to your questions in the Q&A. If you are having any tech issues, please send a direct message to our team, and we will try to help you out and troubleshoot. I want to quickly introduce some of my team members joining me today. I'm here with Danielle Flanagan, Katie Fallon, and Todd Hellenbeck. Together, we're part of the planning team at the San Francisco Bay Conservation and Development Commission, or BCDC for short. And if you're unaware, BCDC is a state agency with planning and regulatory authority over the San Francisco Bay and its shoreline. All of us today on this call support implementation of the Regional Shoreline Adaptation Plan, and you'll hear from each of us in the webinar today. So here's a quick look at today's agenda. We'll begin with our goals for this webinar and a short summary of what we covered in webinars 1 and 2. That will help set the stage for the focus of today, which is on the RSAP Atlas. From there, we'll move into 3 main sections. First, we'll talk about what the RSAP Atlas is, how it relates to the RSAP, and what it includes. Next, we'll walk through the coastal flood hazard layers in the Atlas and why they are important to understand and use. And then we'll focus on how the Atlas can support your planning through a demonstration of the tool itself. We'll end with a few key takeaways and leave time for questions and discussion. Today's webinar goals are to help you understand how the RSAP and the RSAP Atlas are connected, so you can better understand how the Atlas directly supports you in creating subregional plans. We also want you to become familiar with the key tools and features in the Atlas. And finally, by the end of this session, we hope you feel confident to start exploring the RSAP Atlas in your planning efforts moving forward, and know who you can reach out to at BCDC for questions. So to start, we'll just do a quick refresh on what we covered in webinars 1 and 2. This will help bring everyone up to speed and provide some important context for today's session. In our last 2 webinars, we covered a lot of ground, but several key messages emerged that are essential to keep in mind. First, addressing sea level rise requires a coordinated regional response. Flood risks and impacts cross jurisdictional boundaries. Therefore, a regional approach ensures solutions are effective and resilient over time. Second, the Regional Shoreline Adaptation Plan, or RSAP, guides shoreline adaptation planning across the Bay Area. It offers a consistent approach for addressing sea level rise and coastal flood hazards across this larger Bay Area scale. It includes guidelines that outline what needs to be required in a locally created subregional plan to comply with Senate Bill SB 272. SB 272 is a state law requiring jurisdictions around the Bay to create subregional plans by 2034. Third, the plan guidelines, which are included within the RSAP, organize our requirements into 7 plan elements and 4 minimum standards. These provide a clear framework to guide local governments in developing their subregional plans. The plan elements help provide a guiding structure for the process, while the minimum standards set the baseline consistency requirements that every plan must meet. Together, these ensure that plans are grounded in science, prioritize equity, and remain aligned with regional goals for effective adaptation, including prioritizing natural and nature-based adaptation and planning holistically for sustainable development and growth along our shorelines. Lastly, subregional plans link local action to regional resilience. Each subregional plan reflects the specific needs and priorities of its communities, and when combined, these plans form a cohesive regional strategy. This ensures that local efforts contribute to a stronger, more unified response to sea level rise across the Bay Area. And by working together, jurisdictions can align their strategies and build resilience that benefits the region as a whole. So that wraps up our recap of key messages from our first 2 webinars. And so now we'll shift gears and I will pass it to Danielle to dive into the main topic for today, the RSAP Atlas.
Thanks, Jackie. Hi, everyone. I'm Danielle Flanagan, the Climate Adaptation Planning Specialist. In this section, I'll introduce the RSAP Atlas and guide us through what it is and its key components. Before we dive into the RSAP Atlas itself, it's important to really understand the problem it's designed to solve. Developing subregional plans is a complex process that requires extensive data analysis to assess risks, vulnerabilities, and adaptation options. However, many jurisdictions face significant challenges in doing this. They may not have access to the detailed data sets needed for planning, or they may lack the staff time and technical resources to gather and compile this information. So these gaps can slow the planning process and make it difficult to ensure consistency and scientific rigor across the region. The RSAP Atlas was created to really help overcome these barriers by providing a centralized, easy to use data and mapping resource that supports planning efforts. The RSAP Atlas is a regional data and mapping tool created by BCDC to support subregional plan development. It includes about 65% of the data required in the subregional plan under the RSAP. It's designed to reduce the burden on local governments by providing much of the baseline information needed to get started. Using the tool, you can map sea level rise impacts, generate materials for plan submittals, and download GIS data for further local use and refinement. But let's take a moment to be clear about what the RSAP Atlas does and what it does not do. The Atlas serves as a voluntary tool that provides baseline data. It's meant to help you get started, especially if you don't have access to this kind of information already. It offers regionally consistent data sets that align with the RSAP's plan elements, and it provides you a strong starting point for identifying adaptation priorities. It doesn't create a complete plan, and it doesn't replace local data or analysis. You'll still need to fill the gaps and make sure your data is accurate and complete. And just using the Atlas won't guarantee RSAP compliance. Plans will still need to meet the full set of requirements in the RSAP guidelines. So while the Atlas is a very powerful resource, it's just that it's a resource. It's a starting point, not the end point. The RSAP Atlas was developed with a range of users in mind. It supports local governments and public agencies who are responsible for developing subregional plans. It serves consultants and technical staff, offering downloadable GIS layers that can be used in analysis, mapping, and modeling. And it's a resource for community organizations, helping them engage in the planning process by providing access to the same data used by planners and agencies. The goal is to ensure that everyone involved in adaptation planning is working from a common data foundation. Now that you know what the RSAP Atlas is and who it is designed for, we're going to take a little closer look at what's included in the tool. The Atlas has three main components, each built to support different types of users and needs. First are the user guidelines, which are step-by-step instructions that walk you through how to use the Atlas. These are really helpful for anyone just getting started with a tool or needing a refresher on how to utilize it. Next is the Map Explorer, where you can visualize data on sea level rise, groundwater, storm surge, and more. The Explorer lets you generate maps to support your plan submittals. And then finally, for more technical users, there are data downloads, which are GIS files that can be used in your own systems or analyses. We'll explore these in a demo in part 3 of the webinar. As we explore the RSAP Atlas, it's important to highlight where the data comes from. Understanding the sources behind the data can really help build confidence in using the Atlas. The Atlas draws from over a dozen trusted agency partners, including NOAA, the United States Geological Survey, or USGS, ABAG, the Association of Bay Area Governments, and the Metropolitan Transportation Commission, MTC, and several others. This data is consistent with what is required in the RSAP guidelines, and it's updated periodically as new science becomes available so that you're always working with the latest data. So now we want to hear from you. We want to know, are you someone who will start with the user guidelines? Do you want to jump right into exploring maps? Or are you going to go into the data downloads and start downloading data? Drop your answer in the chat and we'll just take a moment to see what everyone is thinking. Okay. You can explore maps and a lot of data downloads. Awesome. Keep them coming. Great. So many, lots of different answers. Thank you everyone for sharing your thoughts in the chat. This is really great insight for us. And we'll keep these preferences in mind as we continue to build out resources. Now I'm going to hand it off to Katie, who's going to walk us through the coastal flood hazards included in both the RSAP and the RSAP Atlas and what they mean for your planning efforts.
Thanks, Danielle. Hi, everyone. I'm Katie Fallon. I'm an environmental scientist on BCDC's Adapting to Rising Tides Data and Science team. And in this section, I'll provide an overview of the coastal flood hazards, why they matter, and the data behind them. But first, it's important to remember that consistent sea level rise scenarios are the foundation for good planning. So let's start with a quick overview of the sea level rise scenarios used in the RSAP before we dive into the hazards. The RSAP and the RSAP Atlas uses specific sea level rise scenarios based on the best available science from the 2024 California Sea Level Rise Guidance. While we know sea levels are rising, our understanding of how quickly they will rise continues to be refined by advancements in science. This guidance, developed by the California Ocean Protection Council, is based on scientific findings from the Intergovernmental Panel on Climate Change's sixth assessment report, data from the National Oceanic and Atmospheric Administration, or NOAA, and California's fourth climate change assessment. It outlines projections under different emission scenarios and timeframes, providing planning benchmarks that ensure consistency and credibility across jurisdictions. Subregional plans are required to use specific minimum scenarios for 2050 and 2100, including intermediate high, and high projections. These include 0.8 feet for 2050, and for 2100, 3.1 feet or the intermediate scenario, 4.9 feet or the intermediate high scenario, and 6.6 feet or the high scenario. Using these consistent scenarios ensures all jurisdictions plan with the same assumptions about future flood risk. In addition to using specific sea level rise scenarios, the RSAP defines 4 coastal flood hazards that must be considered in every subregional plan and are included in the atlas. These hazards represent different ways that shoreline areas can flood. Some of these hazards are already occurring, and all are expected to become more frequent with sea level rise and climate change. These hazards include tidal inundation, measured at mean high or high water, storm surge, emergent groundwater, and shallow groundwater. Each hazard layer in the RSAP Atlas is built using trusted data sources. For tidal inundation and storm surge, we use BCDC's Adapting to Rising Tides maps, which incorporate local flood protection features. Groundwater data, including emergent and shallow groundwater, come from the USGS Coastal Storm Monitoring System, also known as COSMOS. All this data is combined to provide consistent, regionally aligned hazard information. Now let's walk through the hazards one by one. Let's start with tidal inundation. This refers to permanent flooding caused by sea level rise where tides move farther inland over time. Areas that were once dry or only inundated at high tides will begin to see permanent inundation. The Atlas hazard maps add future sea level rise to present day mean high or high water to show how this flooding expands under different sea level rise scenarios. This hazard is critical because it represents areas that will be regularly underwater at high tide, affecting homes, roads, parks, and natural habitats. Understanding tidal inundation helps planners prepare for these permanent changes to the shoreline. Next, we will look at storm surge. Storm surge is a temporary flooding caused by coastal storms. As sea levels rise, these storm surges will become more frequent and reach farther inland. In the atlas, we model storm surge by adding about 3.5 feet of inundation to each of the sea level rise scenarios. This estimate comes from a 2016 regional study on extreme tides and storm events. Understanding storm surge helps communities plan for these intense but shorter-term flood events that can cause major damage. Now let's talk about emergent groundwater. This is groundwater that, as sea levels rise, pushes up the groundwater beneath us. In some areas, this will cause the water to reach the surface and cause flooding from below. In addition to tidal inundation and storm surge, the atlas shows areas that are predicted to experience groundwater emergence at each sea level rise scenario, helping planners understand where and when this kind of flooding might occur. Emergent groundwater is especially important because it can lead to flooding in areas further inland than you might expect from tidal inundation and storm surge. Finally, there's shallow groundwater. While caused by the same phenomena as emergent groundwater, shallow groundwater rise refers to groundwater that is within 9 feet of the surface and is influenced by sea level rise, but has not yet reached the surface. While it doesn't reach the surface like emergent groundwater, it's close enough to affect underground infrastructure like utilities, it can mobilize contaminants, and it can affect things like basements and roads, often in ways that aren't immediately visible. The atlas maps show where shallow groundwater levels are rising under different sea level rise scenarios, giving planners insights into risks that might not be obvious on the surface. If you're interested in digging deeper into the data and methods behind these hazards, we provide a detailed methodology in the data sources and analytical methodology report, which Kat just dropped in the chat. Now that we've reviewed the 4 coastal flood hazards required in the RSAP, it's important to understand why they matter and why they need to be considered together. These hazards often overlap, creating compound risks that can increase flooding and damage beyond what any single hazard might cause. Effective planning must address all of these hazards collectively to avoid unintended impacts or gaps. Understanding these overlapping risks is just the first step. Because these hazards change and expand with different amounts of sea level rise, using the consistent sea level rise scenarios we discussed at the beginning of this section is essential to understanding impacts. The RSAP Atlas maps the hazard layers for each required sea level rise scenario and provides summaries of assets exposure to support plan development. It's important to acknowledge that the required hazards are not the only flood hazards that jurisdictions should be aware of. Jurisdictions are encouraged to consider additional hazards like wave runup and riverine flooding in their adaptation plans if data is available locally. However, because we don't have regionally consistent or high-quality data for these hazards, they are not requirements in the RSAP, and data is not provided in the atlas. Now that we've covered the sea level rise scenarios and coastal flood hazards, we'd like to hear from you. Which of these required hazards are you the least familiar with? Please drop your answers in the chat. Seeing emergent groundwater, all of the above. Great. Emergent. Thanks for sharing your experiences. Feel free to keep them coming. This is helpful information because your input helps us recognize where more support might be needed as you use the atlas. If questions have come up for you about any of these hazards, feel free to submit them in the Q&A below so we can respond to them at the end of our presentation. Now that you understand the coastal flood hazards and sea level rise scenarios, we'll move into part 3, which might be the most exciting section as it includes the atlas demo. To guide us through how the atlas helps with planning, I'll hand it over to Todd.
Thanks, Katie. Hi, everyone. I'm Todd Hollenbeck, the GIS Specialist Lead at BCDC. Before we jump into the Atlas demo, I'm going to briefly review how the Atlas links to the key plan elements of the RSAP and how it assists you in meeting those RSAP requirements. As Danielle mentioned, the Atlas has 3 main components, including the Explore map, user guides, and data downloads. The majority of users, although maybe I'm seeing that a lot of folks will be going straight to the data downloads, but the majority of users intended to go through the Explore map component. This allows you to visualize data on hazards with the Coastal Flood Hazard Explorer, map strategic regional priorities and other data sets with the map layers, and generate plan submittals with the Plan Assistant. I'm going to be demoing all of these tools, but we'll spend a little bit of an additional time with the Plan Assistant since it most directly supports your planning. So the Plan Assistant helps you quickly find the specific data you need to meet RSAP requirements. You can search by jurisdiction, plan element, topic, sea level rise scenario, making it easy to zero in on what's relevant to your plan. The Plan Assistant streamlines your process by helping you create many of the maps, tables, and summaries required by the RSAP. Before we jump into how the Plan Assistant supports your planning, here's a quick refresher on the RSAP plan elements. These are the key steps in developing a sub-regional shoreline adaptation plan, from describing your shoreline to assessing risks and identifying strategies. The plan elements provide a clear structure for planning and ensure consistency across the region. Now let's look at how the Atlas helps with elements A, B, and C. So for element A, the Plan Assistant helps you identify your planning area, potential partners, opportunities to coordinate across jurisdictions, and vulnerable communities. For element B, it helps you map existing shoreline conditions and strategic regional priorities, and highlights where local data may be needed to fill regional gaps. For element C, it helps you visualize the coastal flood hazards, analyze where critical assets are exposed, and start to summarize key exposure findings. So while the tool works really great, and I'm looking forward to having folks start to use it, live demos are very scary. So this is a quick recorded demo highlighting the key features of the Atlas and how it will help you in your planning.
We know local governments are coming to the RSAP from different starting points. So we want to make this information available in a variety of ways depending on where you are. If you're new to the Atlas or the RSAP, user guides are step-by-step tutorials that'll help you navigate the RSAP Atlas. For more technical users, we provide downloadable GIS data for integration into your own analysis. For the majority of users, you'll go to the Explore Map section of the Atlas. Before you get there, you'll need to accept a user acknowledgement agreeing to our terms and conditions, including the user's responsibility for reviewing the accuracy and completeness of data that they're using for their plan. In the Explore Map section, you can generate plan submittals using the Plan Assistant, understand what could be at risk of flooding with the Coastal Flood Hazard Explorer, and visualize RSAP data using the map layers and legend tools. I'm going to dive into the Plan Assistant to show you how the Atlas can support your planning for elements A, B, and C. The Atlas supports element A through the Plan Assistant by providing information on potential partners in planning and providing key data on vulnerable communities. First, you can select your jurisdiction type and jurisdiction. In this example, we'll be planning for the city of Alameda, though census designated places, counties, and operational landscape units are other options as well. Next, let's select element A and a topic to get started. In this example, we'll be working on the identification of vulnerable communities. The Table tab here displays information relevant to your selection, here showing community vulnerability and Calvin virus screen data, and these can be expanded and exported to help you define and identify socially vulnerable populations. The Plan Assistant also can help you to identify your planning partners, your planning area, and multi-jurisdictional coordination opportunities. Data in element A is not required to be used, but is intended as a starting point to make decisions and verify local conditions. The Atlas supports element B through the Plan Assistant by providing data about physical, ecological, and social conditions. In this example, we're planning for the Napa-Sonoma OLU, or Operational Landscape Unit. Next, let's select element B and a topic to get started. In this example, we are mapping existing ecosystem health and resilience conditions. As with element A, the Tables tab provides lists or summaries of assets to help you describe existing conditions. These tables also highlight where an asset represents a strategic regional priority. These can also be exported as CSVs. We also highlight where you can get other resources, not in the Atlas, to help fulfill RSAP requirements. Here, linking to the SFEI's Balin's Resilience Framework report and the data to help you describe ecosystem service characteristics. Map data can be turned on and off in the Layers tab. The Ecosystem Health and Resilience Conditions topic is also where we highlight nature-based adaptation suitability. These maps can be exported to share and identify your existing conditions using the print tool. An error may occur when trying to use the print tool due to the request size limitations. Try reducing the number of layers, zooming in, or capturing the map with a screenshot instead. The Atlas does not provide all information needed to create a plan. The Data Gaps tab highlights those data layers that are not included in the Atlas due to a lack of regionally available information. Local governments must make meaningful efforts to collect this data locally. The Atlas supports element C through the Plan Assistant by providing asset exposure analysis for each of the 4 required sea level rise scenarios. In this example, we'll be planning for Contra Costa County. Next, let's select element C and a topic to get started. In this example, we'll be mapping critical infrastructure exposed under the 3.1 foot sea level rise scenario. Tables provide lists of assets to help you describe exposure and understand strategic regional priorities. Maps can be used to visualize the exposed critical infrastructure and services. and assets. And the stats help summarize exposure by comparing the exposed assets in the jurisdiction to the totals within the jurisdiction and also the region. It's important to note that we use modified geographic boundaries reflecting the bay shoreline, bay watershed, and bay coastal flood hazards, and do not include those assets in areas outside the RSAP analysis area. You can also click on an asset in the map to get additional information about hazard exposure, strategic regional priority status and methods, and then also links to technical reports. The Atlas does not directly assess vulnerability, which requires analyzing sensitivity, adaptive capacity, and potential consequences. So that's the Plan Assistant. But if you want to dive deeper into the exposure analysis and look at impacts of individual hazard types, the Coastal Flood Hazard Explorer includes maps of the RSAP coastal flood hazards and sea level rise scenarios, helping you see how flooding at different sea levels could impact people, buildings, and services. In this example, we're exploring regional transportation exposure under the 3.1 foot sea level rise scenario. You can select all the hazards or an individual hazard type to visualize just those hazard layers and the exposed assets. For example, let's select emergent groundwater. The hazard layer symbology is simplified here, but you can see further information by clicking the asset. Sometimes you may see more than one hazard listed for the scenario that you've selected, and this indicates that the asset may be exposed to more than one hazard. All those hazards should be considered when developing adaptation strategies. Some local sea level rise impacts have regional consequences. For example, a flooded highway in one location can disrupt traffic far beyond the impacted area. The RSAP identifies 8 strategic regional priorities to help focus local efforts on the most critical regional issues. Local governments must address them in plans when present. The Atlas provides map layers of all the strategic regional priorities. In order to see strategic regional priorities, you can expand this list in the map layers and toggle on the visibility of the topic area of interest. In this case, we'll be selecting shoreline contamination strategic regional priority. You can click again on any individual asset to get pop-ups that provide additional information about the strategic regional priority analysis and criteria that helped identify it. Understanding the source of a data set is important in helping local governments assess its suitability for use in their plan. In some cases, local governments may have data that is more suitable for fulfilling plan requirements. We encourage you to use locally refined data representing hazards or assets when available. The Atlas provides access to information about our data sets in the Resources tool. Here you can select metadata and the data set of interest and get additional information about the sources, any methodology and analysis or processing steps that occurred, as well as information, again, about the strategic regional priorities relevant to that topic. Finally, local governments who are more advanced in their plan development, are planning with their neighbors, and or have high technical capacity may want to integrate Atlas data into their existing analysis. The Atlas provides most data sets and analysis available for download through the RSAP Open Data Portal. The data in this Open Data Portal come from a variety of sources and are provided as is for planning use only. You can search for a data set or browse our catalog to find what you're looking for. Once you've clicked through, you can identify the layer of interest and find the data available for download in a variety of formats. These include tables, CSVs, shapefiles, file geodatabases, and the data can even be imported into an existing web map.
Well, hopefully that was informative. We have many more recorded demos of Atlas functionality in our user guides component of the tool. So please feel free to check those out as you start using the Atlas. Before we move into resources and next steps, let's quickly recap the main takeaways from today's webinar. So number one, the Atlas is a planning tool, but not a substitute for your local analysis or decision making. The Atlas includes much of the data needed for a plan. The local governments are responsible for filling data gaps and ensuring the appropriate use of that data for their planning. The Atlas contains all the four required coastal flood hazards and uses consistent science-based sea level rise scenarios. And finally, that RSAP Atlas will evolve and change based on user needs and the best available science. I know that has been covering a lot, so we want to make sure you know where to find everything. You can access the Atlas at rsap-atlas.bcdc.ca.gov, and that is including our step-by-step user guides and data downloads. I do want to emphasize that this is a beta version of the RSAP Atlas. We're still working to improve it and are interested in hearing about your feedback, especially as people start using it to create their plans. If you have questions, ideas, or run into issues, please email gis@bcdc.ca.gov. We'd love to hear how it's working for you. Finally, I want to give a bit of a thank you to a lot of the people that helped get us to this point. That includes OPC and the Coastal Conservancy for funding the development of the Atlas, SFEI for San Francisco Estuary Institute for the web and application development, and the members of the data and mapping subcommittee who really guided us through this whole process. So I'll turn it back over to Danielle to share a few additional resources, next steps, and kick off our question and answer.
Thanks, Todd. In addition to the Atlas, BCDC is here to help during your planning by providing a dedicated liaison in your county, office hours for questions that you might have, our website, which links resources like all of our past webinars, the Bay Adapt Currents dashboard. We have so many resources, so please check out our website. We will share links to this webinar and the slides on our website as well if you want to come back and look at those. Next slide. All right. Finally, we have some great upcoming events. First, we have the second annual Rising Together Summit on September 15th. Tickets are almost sold out, so please go and register soon if you want to go to that. And on September 17th, we have our final webinar in the summer series. Webinar 4 is all about getting started, including how to engage with BCDC, how to access funding, and how to really just begin developing your subregional plan. Additionally, we would love your feedback on the webinar or series, and for you to sign up for our newsletters, you can stay informed. So please also take a look at that.